Why are some websites and apps you use trash, while so many of the games you play are so masterfully put together? The challenges that business faces when it comes to software development is quite massive at times, and so it makes sense that they would spend quite a lot of money on their own software development teams. Even medium-sized businesses will spend millions of dollars per year on their own software development teams. Well-funded game studios also spend millions of dollars on software development teams. The games that sell well and receive the most critical acclaim are the ones that have had thousands and thousands of hours into making sure that these are highly polished products. They want to make sure that everything doesn't just work, but everything works well and is pleasant to experience. After acquiring over a decade of programming experience, I've worked on some of the most boring products and some of the most exciting. Companies that have a single customer and one company that had over 100,000 customers. I've written software in both businesses and games. And I'm here to tell you, businesses need to have a lot fewer excuses than they do for their software quality.
All things being equal, whose website do you prefer? The one that has no bugs and loads instantly, or the one that is down each time you're trying to pay your bill and takes 10 seconds to load your account page?
Even if you don't consciously think about these things, they're in the back of your mind. You like the better experience that is faster and easier and loads quicker and produces less friction throughout your day. Some people I've spoken with in the industry try to act like these little things don't matter or that they're not worth spending time on. But the entertainment industry, the experience, is their everything. They know that if they don't get the experience right, their entire business, which is the experience, won't go anywhere. I think we'd be dishonest if we tried to say that there is nothing we can learn from the entertainment industry, especially the video game industry, on this particular subject. What's stopping business from making their software better? Or how do we even know that it's possible for them to make their software better in the first place? To investigate this, we have to consider how businesses typically go about making their applications. In the modern era, businesses are not going to be creating apps or websites from scratch. They're going to use either open source software solutions or purchase tools or frameworks from around the marketplace. Point being, you don't just open up a code editor and start hammering away. Instead, companies will pick out tools and platforms. What happens if the framework or platform you pick has fundamental flaws and is highly complex? That means that you begin building on top of that, with the platform you've picked being a suboptimal foundation, making a complex system even more complex and more expensive to maintain. Development teams often know about these negative drawbacks, but hey, as the saying goes, don't reinvent the wheel by making a new website framework for the entire engine that powers your business. Why make something that perfectly serves the needs of your business? If you were to do that, that'd be reinventing the wheel. Your business already has a website, so there's a wheel for that already. Don't reinvent the wheel. No one would ever reinvent the wheel for any reason. Ever. That was weird. What just happened? Video games know no such avoidance of reinventing the wheel, and that's because we know that for every single video game, the experience may be fundamentally unique, even if it takes inspiration from previous designs. Or, in instances where a game mechanic is being copied, maybe there's something like a game engine asset from the Unity Game Engine Asset Store, or something. Somehow that particular thing ends up being unique to the game, unique to the experience. Business applications are almost always solved on the basis of business requirements. Enhancements, improvements, just making life better, these things are rare in the typical business-driven corporate environment that we know from conventional business.
This is sometimes described as a dichotomy between pragmatism and purism, or business versus art. But that's a false dichotomy. Those two things are more closely related to each other than society's leadership tends to ever acknowledge.
But with software code, this isn't really how things usually work. Automations that are built out to perform work, scheduled jobs that process data in the background, these things overlap. Often, it is not possible to change one thing without affecting another. And this is one of the primary causes of bugs in software. The human mind fails to adequately account for the complex nature of many variables and data transformations, all intermingling with each other. Correcting these overlaps the right way often requires confronting the rigidity of the code. It means what's known as refactoring, or reworking how instructions are set up to conduct processes. This is undesirable for the business sometimes because it means having to spend money in order to completely rework something that worked before, and may have to work differently now. Games have much less of an issue with this because what matters in games is the experience. What matters to business is that expenses are less and profits are higher. Here's the problem though. If you're not willing to spend money to rework features that overlap with each other, maybe that provides you a short-term benefit the very first time you do it. The second, the third, the fourth time? Some of these business applications or systems survive for over 40 years. A lot of banking software that's running out there at the time I'm making this video dates back to the 1990s or even earlier, running on programming languages like C or Fortran. You often don't really know how long these systems are going to have to be maintained. It's the right answer then to make sure that overlapping parts are reworked properly where needed. Will that, in the short term, ever fit within the definition of business requirements? I'd like to conclude by showing you Salesforce, the development platform that is often called a customer relationship management or CRM platform. Salesforce is used by lots of companies out there to build custom tools, track customer data, create canned reports, lots of useful things. Back in 2015, they released their brand new JavaScript-driven user interface called Salesforce Lightning. Here's the speed at which pages load in Lightning. Here's their old interface, now called their classic interface, which loads quite a bit faster. I've worked projects on Salesforce before where both the developers I was working with and the users within the business we were making features for wondered if Salesforce was capable of handling something like processing a few hundred records. After all, a lot of people know Salesforce as this application where you're entering data on dozens of different forms. You're entering one record at a time, so in the event where you have to migrate hundreds of records, it can seem like a stretch when your interaction on a single record can sometimes feel like it's on the verge of being broken because there's just too much stuff going on in the background on the server as you're saving individual records. A lot of this comes back to people's general expectations about technology and understanding how fast computers actually are. I've worked on solutions that have had Salesforce processing tens of thousands or hundreds of thousands or even millions of rows of data. It can certainly do it. But how fast is the native code running on Salesforce? To understand this, I compared the native programming language on Salesforce, Apex, to what is currently my primary programming language, Rust, to see just how fast each of these programming languages could perform arithmetic. It turns out Apex is thousands of times slower than Rust, because Rust is running locally with no latency waiting over the web. It compiles to native machine code, while Apex compiles to abstracted bytecode and has a heavy interpreter layer. And there's also just other weird stuff that we don't know about, because Apex is a black box technology. In other words, it's proprietary. Salesforce hasn't told anyone exactly how it works. We just know that it's doing something under the hood, but they only give us vague hints about what those things are. Don't understand anything I just said? Don't worry about it. The more important point is how the Salesforce Apex programming language product managers have responded when people ask them these kinds of questions. For one, they don't see this as a problem. Moreover, one of Salesforce's own engineers was once asked what an Apex 2.0 would look like if they were to ever do it. He responded, Java. No, seriously, here's the clip.
My name is Josh Kaplan. I will be taking you through how we compile Apex.
What about an Apex 2 or something where you don't have to worry about legacy?
It's been brought up. I think if I were to, I don't know, if we were going to have Apex 2, I would call it Java, and I would say run applications using Heroku and connect them into using external services and other functionality that we're doing.
While we're talking about our regular experience of how fast web pages load and just think about all the different ways in which we interact with that in our daily lives, I wanted to play you a montage of some of my favorite video games, just so that we can get some perspective on what computers are capable of in terms of performance. Hey, thanks for watching. We could talk about this topic for a very long time, but unfortunately we're out of time. If you have specific questions that you'd like to ask about the capabilities of video games or business applications, or if you'd just like to let me know that you'd like to see more videos on this topic, please leave a comment down below. Also, make sure that you subscribe and hit that like button on this video before you go. You can find me on all my other social media channels that are available in the information from the description on this video, and you can check out the Elega Corporation website at elegacorp.com. Oh yeah, the Elega Corporation website. You're watching the Elega Corporation YouTube channel, by the way. Folks, I will see you next time.